Good morning, good afternoon, and good evening. It's my privilege today to introduce David Rios Insua, who's going to be talking about a cybersecurity risk analysis Bayesian framework for systems with artificial intelligence components. David, please take it away.
Okay, thank you. Thanks, David, and thanks, Isvan and the Industrial Stats section for inviting me to talk. It's night here, and I try to do my best not to sleep. So this is joint work with three colleagues. Chema Camacho he's a PhD student, and Aitor Couce is an economist, a security economist, and David Arroyo is a colleague who works on cybersecurity. He's an IT engineer. At least there's one version of the paper there, so I mean you can check there the sort of mathematics and so on, and hence I will basically give a sort of some ideas on the sort of concepts, the details. You can find it in the paper, and we shall release software. We already have it, but we'll release it if the paper is eventually published, with details of the case study and sort of you can follow the process, etc., etc. Okay, so that's my plan. First, I would like to speak why there's a need for a sort of risk analysis framework for artificial intelligence based on a number of risks, new risks that have emerged, and also based on the policy landscape, which is changing, especially. I mean, the talk will be influenced by, I mean, the recent developments in Europe. Then I shall emphasize what are the new, I mean, what is new in relation to risk analysis in reference to artificial intelligence, artificial intelligence components and services and so on. And then I try to give some solutions to those issues and how can we integrate them in this framework. I will give an example of a simplified version of an automatic driving system as a prime example of applications of artificial intelligence technology. And finally, some discussion and some challenges and so on. Okay, so let me start first with the need for this framework. First, I mean, everybody reads every day like quite many news of new things that are being done with artificial intelligence or machine learning. And some of them are good. Like, for example, this has allowed to speed up research processes, for example, in drug and material discovery, or it has allowed to introduce radically new technologies, and the prime example would be automated driving systems. It has also allowed, for example, to amalgamate masses of data and expert judgment, and one example would be medical technology, and that would be an example they referred from colorectal cancer screening, and also in supporting complex decision making. For example, the work that we did on aviation safety to support the Spanish risk management program. These are all examples from our lab. But of course, the prime talk at the moment in relation to this is our large language models and transformers. So these are the good things, but there's bad things. And I've put here an example. I mean, each of these applied applications, I put a sort of bad example of bad things that you can do. For example, the same technology that you can use to develop new drugs, you can use it to develop biochemical weapons. You can fool an ADS to become a weapon, actually. You can commit insurance fraud by intelligently distorting medical images. And you can, well, there's a number of cybersecurity challenges based on artificial intelligence in aviation. So one good example, one bad example. And of course, in relation to LLMs, there's the very important problem of deceptive alignment, which is a sort of major issue. And how do you scale responsibly those systems, which is a major discussion at the moment. So this talks about novel threats in a fast changing world. By the way, this is the industrial section of ISVA, and well, industry is super affected by artificial intelligence. So I think it's quite timely to talk about this in ISVA. So as an example of how this is penetrating public opinion, I put here the ranking of major risks as viewed in the World Economic Forum Global Risk Report that they produce annually. And you can see, for example, in a sort of long-term horizon, like 10 years, they go through a pool of experts, etc. But you can see that the adverse outcomes of AI technologies start to emerge as a major thing to worry. The last 2 years, in a sort of 2-year horizon, you can see extreme weather events, societal polarization, misinformation, and so on, which are in the current agenda. But my emphasis is that AI technologies are starting to become a major issue in public opinion. Also, we had to do this for the European Union, this strategic crisis management report on how do we do, how do we handle those crises at the European Union level. And one of the issues that one of the case studies was concerning artificial intelligence systems. So, it's in the policy. And as a consequence, there's been a recent and upcoming policy acts. The first one would be the NIST Artificial Intelligence Risk Management Framework in 2023, which basically it's essentially a qualitative report pointing out issues, problems, etc. But then, as far as risk analysis is concerned, it points out to previous or to other documents by NIST, and it happens that they are based on risk matrices, for example, which have some defects. Biden's executive order on safe, secure, and trustworthy AI from last year as well. For example, one of the things that he mentioned was that the NIST ARAMF needed to be redefined or rewritten to take into account large language models and generative artificial intelligence. And this last May, we had in Europe this Artificial Intelligence Act, which is the most, I think it's the first global law to regulate risks in artificial intelligence. And I was saying upcoming policy acts, China is as well working on a regulatory environment so this is a sort of global issue. I've taken here a little bit from the Act. That's the version of 2024. That's the current version. And just to put some definitions, there's a definition on what is AI according in this law. And well, basically, this is software that helps to make predictions, content recommendations, which can influence physical and virtual environments. And it's interesting to mention that the techniques that enable inference, etc., are basically machine learning approaches and logic and knowledge-based approaches. Machine learning approaches would be the sort of trendy topic in artificial intelligence. Logic and knowledge-based would be more like the old AI style. As a side comment, I would like to point a sort of kind of anecdote from the version of 2022. Actually, the techniques that were mentioned in 2022 were slightly different, and it's kind of nice that one of the three blocks of techniques was referred to statistical approaches, and it was even mentioned Bayesian estimation. I think it's the first law which mentions Bayes, but then in the sort of rewrites of the law, it didn't. This chunk disappeared. So unfortunately, there's no law mention it yet. Okay. I would like to another thing that it's interesting to mention the number of times that the word risk appears in the act. It is 617, and the act makes a classification of systems like a four-ladder. So it talks about systems that should be forbidden according to the sort of common practice or the sort of fundamental laws that are acceptable in Europe. But they also talk about high-risk AI systems and well, well, it's a whole other thing. And the most interesting are, I mean, from the point of view of modeling and risk analysis, are these high-risk AI systems, because they ask explicitly for risk management systems that need to be sort of produced, right? So that's sort of a good opportunity both for research and for business. And my claim is that the same that the GDPR, that was another law which was like 4 or 5 years ago on data protection, another European law which marked an explosion of interest on explainable artificial intelligence. My claim is that this act will make an explosion on secure artificial intelligence, and we'll see in the next few years whether my claim is true or not. Okay, so that's the need. Let me talk now on what I think are the novel issues, the new issues that need to be considered. I'm putting here in this work we are starting with first one standard from there's many standards, cybersecurity standards, but we've adopted the sorry, what is called the Information Security Forum. And based on that, we did some work on cybersecurity risk analysis and some book, etc. So that's how initially view the cybersecurity risk analysis. Basically, we have an organization with assets and certain features, etc., which is, I mean, it's swimming in an ocean of threats. So there's environmental threats, but there's non-target cybersecurity, cyber targeted threats, and non-targeted threats, right? And there's attackers. These threats produce some impacts. Some of them could be insurable, others could be non-insurable. And to protect from those threats and impacts, we can adopt a cybersecurity portfolio. So this cybersecurity portfolio could include security controls, but also recovery controls, insurance, and also some constraints. So that's where our starting point, the framework that we developed a few years ago. And there's a number of new issues. The first one is that a number of new assets are based on artificial intelligence. So that's there's new services, new components that are based on AI. There's also new impacts, as we shall see. I mean, new things that threats in this landscape that these threats could produce over the system. There's new threats based on especially we are especially worried about targeted threats that are based on artificial intelligence, as we shall discuss. And finally, you can also introduce defenses like security and recovery controls based on AI. So these are sort of the new elements that we need to take into account. We need to sort of produce new model ingredients if you want. So I'm going to talk on some solutions to those issues, or discuss some possible solutions. I shall explain, I mean, topics that are not that frequently used in Bayesian conferences and so on. So I'll talk a bit about utility functions and multi-attribute utility functions. I emphasize maximizing expected utility, expert judgment modeling, and adversarial risk analysis as a Bayesian approach to games. And the problem that we want to focus on, it's a strategic problem. So we want to devise what's the best portfolio of countermeasures, security controls, etc., to protect a cyber system which has AI components. That's the problem that we want to address. So okay, so now I shall describe some solutions to the issues that I mentioned. The first one is handling AI-related impacts, and from this, we draw on earlier work that we did on general cybersecurity. So, first of all, I would like to mention that there used to be a focus on technical impacts. That's what it's in the jargon of cybersecurity is called the CIA. So it was confidentiality, integrity, and availability of systems as a consequence of cyber attacks. And then we did quite a bit of work to try to sort of overcome this sort of very technical approach and take into account that these impacts have, I don't know, like, they could have economic impact. These threats could have economic impacts, but also they could have environmental impacts. You could actually kill people through cyber attacks, etc., etc., etc. So we try to work on a sort of general multi-attribute utility model, and I'm reflecting here the objectives tree, and based on that we build a generic model, etc., etc., etc. Okay, now with artificial intelligence, there's a bunch of new impacts that various organizations have mentioned. I'm reflecting for here the NIST AI RMF that I mentioned reflects a number of principles and sub-principles in relation to, I mean, that should be prime in managing risks in relation to AI. The the European Act also mentions principles. I mean, there's a European Charter of Fundamental Rights, ISO, there's ALTAI, there's an MIT AI risk report. So basically, you can see here the principles that they propose, like validity, safety, fairness, security, etc. Some of them have like sub-principles. I don't know, for example, security talks about protection and resilience, etc., etc., etc. And what we did was, I mean, what we did was an exercise to try to see if we needed to add new objectives to this tree. And well, basically we were able, I mean, we claim that we did a sort of quite thorough job in the previous wave of work that we did on this, and we can adapt actually all these new principles to the previous objectives. Okay, so the second issue was that we have AI-based assets, and to our initial like black box model that we had with we just added to we just decided to add some granularity to this black box that we were using. And I'm putting here like three examples, very simplified examples. The first one, we'll go through it later on, but this refers to an automated driving system. And basically, you can see this is reflecting the architecture of the system. So you can see a system with which it covers a perception system and a location system, right? And basically, this informs our decision making, and the decision making system takes control of, I don't know, the direction, the speed, etc. And you can see that well, there's attacks. There could be attacks through the perception or the location system, etc., etc. The second one is a threat management system, which you could view as a sort of expanding or increasing the granularity of the perception block. And this threat management system includes cameras, includes some computer vision block or algorithms, and based on the information provided, there's a threat assessment. And again, you could try to fool or interfere with a sort of normal operation through attacks. The final example. The final example um, um, includes it's a marketing content creation system, and basically again it has an interface and it has a couple of intermediate blocks like a database of customers, a lookalike system which tries to identify customers which are similar to ones that you are interested in, and finally a large language model which makes content. It creates content to be addressed to customers, right? And the sort of two things that we want to I would like to emphasize here is first the granularity level. So you can see that this box could be make more detailed. So you must make a sort of decision on how detailed you want to make your architecture. The more detail the more detail is the analysis, but also it entails much more work in as far as modeling is concerned. And also that there are some black boxes. For example, in many cases, I mean, depending on the LLM, that could be like a black box, and you cannot descend. So these are the two issues to consider when you consider AI-based assets. So the third issue refers to defenses, AI-based security and recovery control. So you can build defenses based on machine learning or artificial intelligence, right? Sorry, I forgot this. So the type of architecture that we consider is what is called, I mean, it's similar to what is called a Bayesian attack graph in the cybersecurity literature, but we allow for cycles, as I saw in one of the examples, and we also allow for multiple entry levels. And the sort of architecture is based on the number of levels, blocks at various levels, entrance probabilities. So what is the probability that an attack enters through various, it could be through just the perception or through the location or a combined attack, or it could be, there could be multiple entry levels. And the other parameters that are relevant are these sort of non-protection probabilities. So there is an attempt to attack through in this, but there could be this could be able to discriminate this attack and protect you or not. And what we use is the probability of not protecting from an attack. So there could be in all these parameters are required. So as I was saying, one of these is you could build some of these protections could be based on AI, machine learning methods, etc. And here, one sort of very important parameters are these protection or non-protection probabilities. You need, I mean, you could use standard um, expert judgment elicitation, or you could use data and expert judgment, etc. One ingredient which is quite important in this part comes from adversarial machine learning, and I mean these security evaluation curves that are built. And for example, this refers to how, depending on the intensity of an attack, what is the probability? I mean, what is the probability of performing correctly in a certain task? And so you can build these tasks, these curves, and based on that you can come out with the protection probabilities. The other problem is that some of these attacks, in particular the targeted attacks, could be based on artificial intelligence systems. And there's even, I mean, to sort of make a comment on the sort of relevance of the problem, there's now crime as a service platforms based on artificial intelligence that you can actually rent. So, I mean, you don't need to be a very techie, and you just need to have some money to rent those services to attack, I don't know, somebody or some organization. And the problem with this, I mean, the issues that we need to handle are what we call the entry probabilities. So, what is the probability that you are going to be attacked through this entry? It could be the case that I mean, there are multiple targets. So my organization is a target, but I don't know, Duke University is a target of an attack, or Oakland Universities, and I need to answer, or we need to answer, what is the probability of my organization being the target, right? And quite importantly is, what is the probability of my organization being the target through various attack points and through various attack modes. That's quite important to handle the risks. And for this, we have developed some adversarial risk analysis methodology. We essentially use what we call a defend attack model. And this allows us to, in the sort of, with this methodology, we are able to provide answers to these modeling issues. I mean, these probabilities of me being the target through various attack points, etc. What is the probability of others? We are able to develop this. As I said, you can read the details. I'm just giving the sort of broad idea. Okay, so these were like a sort of description, sort of very high level description of the solutions. And now we need to integrate all these solutions in this framework. Basically, once we have assessed all these parameters, we go through a simulation process. So basically, we need to simulation of attacks into an organization. And basically, we need to, well, simulate those attacks, simulate how these attacks transit through the system, because there could be cycles, or they could visit various blocks, various assets. And finally, once we have found out how the system has been attacked, what are the impacts? So we need to simulate those impacts and then aggregate those impacts. Basically, this simulation thing, we use it for risk assessment. And then if these risks are high enough, then we need to go for risk management, which basically was the question that we wanted to ask. What is the portfolio how do we need to invest to better protect our system? So that would be the sort of picture. I'm just giving like a brief overview of the algorithms, the simulation algorithms. I mean, this is a standard. Basically, these are stochastic processes. we generate from these stochastic processes, and we branch which branch the visits from those processes through various attack points or yeah, through various entry points. The only the kind of exotic thing is that we need to sort of do a first exercise on trying to estimate those whether we are going to the target and with which probabilities are we going to be attacked through various targets. And that's a sort of an adversarial risk analysis exercise that we need first, but then the rest is kind of standard simulation of an stochastic processes, which branches, etc., etc. So once we have an attack in this, then we need to simulate the transit through the facility, because there could be cycles, there's various branches or various paths to follow, and that's how what we reflect. And based on and the output of this is that we find, given an attack, which blocks in our system, which assets have been attacked. And then finally, once we know which assets have been attacked, we need to simulate which are the impacts. Some of them could affect just one of the blocks, it could affect the blocks individually. Some are affect the system as a whole. So once with this sort of way to simulate the attacks and the impacts, then we can proceed through risk management. Basically, we want to find a portfolio which is marked here with C, of maximum expected utility given constraints. Typical constraints would be you have a maximum implementation budget, or you have a maintenance budget. There could be constraints referring to I don't know, technical compliance or legal compliance that forces you to have, I don't know, some type of insurance or something like this. So, this will, I was mentioning before simulation, so you can imagine that, we need some way to compute expected utilities and then some way to maximize expected utilities. This could be quite complex, and well, we have a number of tricks, but well, this is basically technicalities. And then, to give a flavor of the kind of things or practical advice that we can, I'm going back to this example, which is a sort of a simplified version of an autonomous vehicle architecture with a perception system, allocation system, and a decision-making system. There could be various types of attacks. And in the example we consider, there's two competitors. So I'm the owner of a sort of autonomous vehicle taxi company. There's two possible attackers, and there's four types of attacks. And we have structured the case in such a way that we can sort of define a sort of process or a template for other case studies that people might be interested in. So basically, the process that we need to go is first fix the structure, levels, blocks, entry points, and routes of attacks. Then we need to identify the impacts which are relevant in the problem. In our case, was financial, equipment damage, and downtime of the cars. Then we need to think of the threats, non-targeted and targeted, the potential additional defenses that we could include, including the cyber insurance and the constraints. And then once we have structured the problem, we go through a model The non-targeted is basically modeling some stochastic processes and bifurcations. The targeted attacks, for each attack, we need to simulate and optimize to get the arrival process, the targetees, and the entry points. We need to provide models to forecast the impacts and non-protection probabilities, and then we need to optimize, right? So that would be sort of the process to be followed. And that's the example with some numerics. The details are in the paper. In blue is sort of the loss curve that we get if the system is not additionally protected. So you can see, for example, that the probability of zero loss is it's zero basically. And in blue there's a curve with potential losses, and the value at risk is pretty high for the company. And then after this excess risk management exercise, you can see that I mean, we move to the left, so we spend less, and also the probability of zero loss is bigger. So I mean, you can see that with this system, we are able to protect the organization quite a bit. I mean, we get things like what are the best portfolios? This is the status quo. These are the best portfolios. We can make sensitivity analysis in the sense of if the protection budget is increased, how does the optimal portfolio change? How does the expected utility increase, and what is the related expected loss in terms of monetary things? You can check the deterrence effects of this optimal portfolio introduced. And you can see, for example, that I mean, here we had a very high probability of being attacked through an adversarial machine learning attack. But with this thing that we introduce, we get rid of most of this risk, and we transfer it to other agents or other participants. And we can make I mean all other kinds of sensitivity analysis things. For example, we were seeing that the sort of there were two insurance products, A and B. This A product doesn't appear except in the very expensive investments. So if we reduce the price, how are we able to introduce? I mean, to switch from insurance A to insurance B, in case the insurance company is interested in that kind of things. So I'm kind of concluding a discussion. We have introduced a framework to handle risks, the new type of risks, a new type of elements in risk analysis in relation to AI systems and services. And one thing which is important is that it goes beyond the prevalent risk matrices that are being used in cybersecurity. The problem that we have described is strategic, in the sense that I mean, it would be like the typical exercise that one does every year on what are the security investment that we need to implement to make our system more secure. And you could couple it with operational approaches, monitoring systems, learning as data accumulates, etc. Yeah. You can use these kind of things also to. I mentioned before that the European Act talks about a four-level risk ladder. So we could I mean, we could use this kind of thing to I mean, defining certain thresholds to sort of quantify where in that ladder our system is, which is important, I guess, for consulting companies. And I mean, we can start talking about. I mean, the same that people are talking. I mean, and it's products that are, let's say, just starting, which are cyber insurance. We could start on talking about artificial intelligence insurance, and also beyond cybersecurity. I just talk about cybersecurity, but there's a wider problems within the concept of trustworthy AI. So security is just one element, one dimension. You could try to extend this in that direction. So I mean, if you read the paper, you could see that this is a very large. I mean, it entails a very large modeling effort, but I would say it's worth it because the sort of the values at stake are pretty are large. But this modeling effort could be reduced through templates, graphical interfaces, etc. As templates, I mean templates that facilitate repetitive tasks. And for example, a process template, I mean, our paper could be viewed as a sort of a template for the process to follow. But for example, there's lists of AI risks. For example, there's an MIT AI risk repository that so we don't need to, let's say, reinvent the wheel, and we have those lists. There's a list of traditional cyber risk assets. For example, there's methodologies like Margaret, there's NIST, MEARI, etc. There's lists of machine learning attacks from MITRE, etc., etc. So some commercials, some papers, related papers, right? More commercial papers. I take this opportunity. So we have a couple of postdocs at our institute in relation to this, and a couple of commercials on two conferences done by the industrial stats. Bayesian inference, stochastic processes, and games and decisions. Risk and reliability next May in Milano. That's the price that you have to pay for. And well, thanks to the sponsors, a couple of banks and insurance, the U.S. Air Forces, and a couple of European projects. And we started this work while at SAMSI a couple of years or 3 years ago, and the Spanish government is also supporting this through the Securia project. And thank you. If anyone is interested in this, I think it's going to be a pretty important topic in the next few years, and we are working quite a bit on that. We would be super happy to collaborate. And thank you, David and Isva and the industrial sections.
Thank you so much, David. That was great. Let us throw it open for people who have comments or questions.
Yeah, I have a question. Hello, professors. Yes, I'm from China, and nowadays we really have a very specific question. It's very similar, like a trolling problem. It's like on the two row, and one side is 5%, one side is 1%, and the tree has to kill someone. Have to choose the option one to kill 5% another. So in the self-driving cars, we really have that problem. So and I checked the Professor David Rios, he has a paper talking about the changing lines. the changing when the cars are changing lanes. So we really have we have a self-driving car operated in China, like a Uber car, like a taxi car. So nowadays this car really have this problem when in front of the car they see the track. And beside the car is a motorcycle, and another side of the car is a SUV, and behind the car is a school bus, for example. So when they attack, must happen. When the car must attack someone. So what the car should do, and this is also I think this is I think, for example, if you try to attack the motor driver, it is because you only kill one person. But the motor driver didn't do anything wrong and something. But if you hit the SUV, maybe you don't kill anyone because SUV is safer than other cars. But you cannot say SUV is safer, so you hit it. So the problem is we really have this problem nowadays. So I want to know. So do we have any ideas on this? Yeah, this is. Yeah, thank you.
Yeah, sorry, I not very good. I don't know if I understood that it was a question about automated systems, but could some? I mean, did you any of you listen properly?
Oh, you mean you cannot hear me?
There's a very back there's a lot of noise.
Yeah, if you could mute yourself, Hey Sun, that would be helpful. Great. And I believe that Hey Sun was asking about the trolley problem, which is a moral dilemma in which you get to choose between killing one person or killing a lot of people. And how should an autonomous vehicle weigh those choices?
Okay, right. Well, it's a bit. I mean, it's not exactly the topic of the. I mean, it's a bit of a side question. Thank you. So well, we wrote a paper on this. I think you have to view, as I said, it's a sort of quite different to what I talk. You don't need to focus on that sort of, let's say, extreme problem. What we were commenting on that, and I think is the way to go, is that you need to build a sort of a preference model to support the decisions of the autonomous vehicle, right? A sort of generic, and then let it. I mean, make very long simulations with this model to try to come out with. I mean, to adjust the parameters, and I mean to try to come out with safety numbers that are acceptable from a sort of regulatory point of view. And then you put this preference model to regulate the decisions of the car. I mean the trolley problem is a sort of interesting problem. It's an ethical dilemma, etc. But what you have to model is a sort of you have to come out with a sort of preference model that allows the car to operate in all circumstances. And then once you are happy with this, you have tuned this preference model. I mean, you accept from a regulatory point that model, then you allow the car to, and maybe sometime it will have to face this situation and let the car operate with this preference model. That's my point of view. I don't know if. Yeah.
Thank you, David. Anybody else have a question or comment?
It will have to face this.
It seems to me, David, that you have laid out sort of a general strategy, but there isn't going to be general theory. it's sort of, as you said, a template for a calculation. Is that your view?
Yeah. No, I think this is a general strategy. And my claim is, well, this was a sort of very small example. Okay, let's call it toy example, but it gives us lots of work. So my claim is that it's a lot of work, but it's worth. I would like to. I mean, I wouldn't like consultants to repeat what they do in cybersecurity, which is working with the risk matrices, which produce mistakes, etc. Right? I would like, because this is a sort of important problem, society-wise or country-wise or whatever, or continent-wise or whatever, that I would like to sort of go one step ahead and make this more sophisticated modeling. And what I say is that I think we can alleviate this very tough work by producing templates. So we can produce templates for the security curves. There's lists already of AI risks. There's catalogs of assets, and all this I think can alleviate this modeling work. Yeah.
Thank you. Chaitanya has
So that's
raised
why I
his hand.
said there's a business opportunity there, I think, as well.
Thank you. Chaitanya?
Oh, hi, David. Really nice talk. I enjoyed it. And you're absolutely right about the risk matrices. So it's a great solution, I think. I just had one quick question. Would you just repeat the sensitivity analysis you did? I kind of missed that bit.
Yeah, this one?
Yeah. So what was this about? Sensitivity with respect to what?
Yeah, I just put we did and the paper has more examples, but one example is here on this bottom left corner. We move the budget, so that would be the sort of right term of the constraint or budget constraint. So you can see that as we increase the budget, how the portfolio is growing, and how the expected loss is reducing and the expected utility is improving. I mean, you can stop. I mean, you can use this kind of exercise. I believe the initial budget was the sort of nominal value was this one. Yeah, and we also did. Here, this one is the price of the insurance product. If we reduce it by 3%, I mean, in some steps, you can see that in the beginning, the insurance product A is not is appearing. So I mean, you can see here that only with very expensive portfolios, insurance B is adopted. So if I reduce the price of B, then it will start being, and this could be useful. I don't know if the insurance company wants to promote for whatever reason product B to make it to get market share, etc. So you could I mean that would be one exercise that you could undertake, right? These are two
No, sounds
examples.
good.
You could do sensitivity to many other things, many other parameters.
No, that's exactly right. I think there are just so many variables here. So
Yeah,
thanks for the
yeah,
clarification.
yeah. That of course increments the effort, the modeling effort that I mentioned before. Yeah.
Anybody else with a comment or question? I would like to make one small comment. This is the time of the year when one renews one's membership in ISPA. And so it's an ideal time to decide to join the industrial statistics section. I hope many of you will consider doing that. Let's close
Yeah,
by
and
thanking David Rios and Insua one more time.
Thank you. I would like the industrial statistics makes very interesting workshops. like GDRR and BISP, and they are a lot of fun.
Thank you all.
Okay, thank you. Bye-bye.
Thank you very much.
Bye.
Thank you again.
Okay, ciao.
Ciao, ciao.